Hello everyone, I am Shivam Singh, student of Faculty of Engineering and Technology, University of Lucknow in Department of Civil Engineering. Here I am going to present a seminar on the topic of Hydroceramic Wall. Here are some table of contents including Hydroceramic Wall, component of Hydroceramic Wall, how does it work, benefit of it, application, current state of it, future of it, types of it, advantages, challenges, how to install, case study on the topic, and conclusion. Hydroceramic wall introduction. A hydroceramic wall is a composite material made of hydrogel, fabric, and ceramic. It is a passive cooling system that can reduce the temperature of an interior space by up to 5 to 6 degrees Celsius. These walls are a type of wall that is made up of porous ceramic blocks that are filled with water. The water evaporates from the blocks, cooling the air and creating a humid microclimate. This humid microclimate can help to reduce building energy consumption by up to 30%. Here we can see outer sheet of prototype and inner sheet of prototype as well. Components of hydroceramic wall. Hydrogel layer. The hydrogel layer is the main component of hydroceramic wall. It is made of hygroscopic materials such as polyacrylamide that can absorb up to 500 times its own weight in water. This ability to absorb and retain water is what makes hydrogel ideal for passive cooling application. Ceramic matrix. The ceramic matrix is a porous material that provides structural support for the hydrogel layer and allows water vapor to escape. It is typically made of ceramic materials such as alumina or silica. The ceramic matrix also helps to protect the hydrogel layer from UV radiation and other environmental factors that could degrade it. And other minor components like water supply system. A water supply system is needed to replenish the water lost through evaporation. Backer board. The backer board is a material that is used to support the ceramic matrix. Air gap. The air gap is a space between the baker board and the ceramic matrix. Protective coating. The protective coating is a material that is applied to the surface of a hydroceramic wall to protect it from weathering and damage. Insulation. Insulation can be added to the hydroceramic wall to improve the thermal performance. Insulation helps to keep the cool air inside and the building and the hot air outside. Sensors and controls. Sensor and control can be used to monitor and control the performance of the hydroceramic wall. Sensors can measure temperature, humidity, moisture content of the hydrogel layer. Controls can be used to adjust the water supply system to ensure that the layer is properly hydrated or not. How does it work? Here are some steps that explain how does it works. Like first step is water absorption. The hydrogel within the wall absorbs water from a reservoir or ambient humidity which is present in the atmosphere. Evaporation. When the surrounding air temperature rises, the absorbed water in the hydrogel starts evaporate. Cooling effect. As water evaporates, it absorbs heat from the surrounding air, resulting in a cooling effect. The heat energy is transferred the air to evaporating water, causing a noticeable drop in temperature. Humidity regulation. The evaporation process also increases the humidity of the surrounding air, which can help to improve thermal comfort, especially in dry climates. Here are the pictures which explain the thermal checking setup and growth and evaporation cycle in the hydroceramic wall. Benefits of hydroceramic wall. Passive cooling. Hydroceramic wall can cool a building without use of electricity, which can save money on energy bills. Reduce carbon emission. By reducing the need for air conditioning, hydroceramic wall can help to reduce greenhouse gas emission, improve indoor air quality. Hydroceramic wall can help to improve indoor air quality by increasing humidity, reduced heat island effect. Hydroceramic wall can help to reduce the urban heat island effect by cooling the surrounding air. Reduced construction cost. Hydroceramic walls are relatively inexpensive to manufacture and install. This is because they are made up from a combination of clay and hydrogel, which are both abundant and low cost materials. Increased durability. Hydroceramic walls are more durable than traditional buildings materials such as concrete and bricks. This is because they are resistant to fire, mold, and mildew. They are also less likely to crack or break than traditional buildings materials. Application of hydroceramic wall infrastructure. Hydroceramic wall can be used to cool roads, bridges, and other infrastructure projects. Transportation. Hydroceramic wall can be used to cool buses, trains, and other vehicles. Agriculture. Hydroceramic wall can be used to cool greenhouse and other agriculture. Current state of hydroceramic wall technology. Hydroceramic wall technology is still under development, but it has potential to revolutionize the way we cool buildings and other structures. Researchers are working to develop new hydroceramic material with improved cooling performance and durability. They are also working to develop new ways to manufacture and install hydroceramic walls. Hydroceramic wall technology is a promising new technology with the potential to revolutionize the construction industry. It is still under development, but it is already being used in a variety of applications. As the technology continues to develop, we can expect to see even more innovative and groundbreaking uses for hydroceramic walls. Future of hydroceramic wall. Hydroceramic wall have the potential to become a widely used technology for cooling building and other structures. They offer a number of benefits including passive cooling, reduced carbon emission, improved air quality, and reduced heat island effect. As hydroceramic wall technology continues to develop, it is likely to become more affordable and easier to install, making it even more attractive to building owners and operators. Types of hydroceramic wall. There are mainly two types of hydroceramic wall: evaporative cooling walls and radiant cooling walls. The evaporative cooling walls, these walls are used to evaporate water to cool the air, and radiant cooling walls, these walls used to reflect the infrared radiation to cool the air. Next slide. Advantage of hydroceramic wall over traditional cooling system. Hydroceramic wall offer a number of advantages over traditional cooling systems, such as they are more energy efficient, they produce fewer emission, they are more sustainable, they are more durable, and they are more affordable as well. Here is the graph showing hydroceramic effect on temperature and humidity, which I have taken from image courtesy of IAAC Institute of Advanced Architecture of Catalonia. Challenges in hydroceramic wall. They can be more difficult to install than traditional cooling system. They may not be effective in all climates. They may require regular maintenance. How to install a hydroceramic wall? Hydroceramic wall can be installed in a variety of ways, depending on a specific type of wall and the application. However, there are some general steps that are common to most installation. Prepare the surface, apply the hydroceramic material, install the support structure, connect the water supply, and test the wall. Here are some case study, like first case study, Hydroceramic Wall at Green Building in Los Angeles, CA. The Green Building in Los Angeles, CA is LEED Platinum certified building that is known for its sustainable design and features. One of the building's most innovative feature is hydroceramic wall. The hydroceramic wall at the Green Building is located on the south side of the building. The wall is 100 feet long and 20 feet high. It is made up of over 10,000 ceramic blocks. The wall has been very successful at reducing green buildings' energy consumption. The building uses 30% less energy than a comparable building without a hydroceramic wall. Case study 2. The National Museum of Singapore is a home to a stunning hydroceramic wall that was installed in 2014. The wall is made up of over 2 lakh ceramic tiles that have been coated with a special hydrogel. This hydrogel has the ability to absorb and retain water, which helps to keep wall cool and humid. The wall also features a series of embedded sensors that collect data on environment such as temperature, humidity, and light levels. The data is used to control the amount of water is released from the hydrogel, ensuring that the wall is always at the optimal temperature and humidity. Case study 3. Kanchenjunga Apartment, Mumbai, India. Kanchenjunga Apartment is a LEED Gold certified residential building in Mumbai, India that utilizes ceramic wall and roof to reduce the energy consumption by 30%. The building's hydroceramic facade consists of series of fabricated panels that are embedded with the hydrogels. The hydrogel absorb water from the air, which evaporates and cool the surrounding air. The ceramic matrix provide structural support to the hydrogel and protect them from damage. Case study 4. Milwaukee Art Museum, Wisconsin, USA. Milwaukee Art Museum, Milwaukee, Wisconsin, USA feature a hydroceramic facade that helps to regulate building's temperature. The museum's facade consists of a series of panels that are embedded with hydrogels. The hydrogels absorb water from the air, which evaporate and cool the surrounding air in the summer. In the winter, the hydrogel release the water vapor, which condenses the releases heat, warming the surrounding air. Hydroceramic can be used to reduce energy consumption, improve indoor quality, reduce reduce a building's carbon footprint. Research continues and manufacturing costs decrease. We can expect to see hydroceramic used in even wider variety buildings and products. Conclusion. Hydroceramic wall are promising new technology for cooling building and other structure. They offer a number of advantages over traditional cooling system such as energy efficiency, sustainability, affordability. As hydroceramic wall technology continues to develop, it is likely to become even more widely used in the future. Hydroceramic walls are sustainable and energy efficient technology that can use in a variety of applications. They offer a number of advantages over traditional wall, including reduced energy consumption, improved air quality, reduced noise pollution, and increased property value. As the cost of hydroceramic wall decrease and more people become aware of their benefits, they are likely to become more popular in the year to come. Thank you.